Again, welcome to Statistics course. This is DSRT 734 class. In these lectures, we're going to continue with our hypothesis testing topic. And this time, our main objective is hypothesis testing with two samples. That's two independent samples. So our main objective is to perform a t-test to test the mean of the difference for a population of pair data. So again, here we are going to test two different samples, two dependent samples, hypothesis testing. We are going to use the t-test. So t-test for the difference between means. So here we have two samples. First thing we need to do is to find the difference between the two mean. So first, to perform a two-sample hypothesis test with dependent samples, the difference between each data pair is first found. So here we have two samples. So we have one pair of data for each. So for example, here we find the D, which will be S1 minus S2. This means the first value of the first sample minus the first value of the second sample. So again, here we are saying to perform a two-sample hypothesis testing with dependent samples, the difference between each data pair is first found. So to find the difference between the entry for a data pair, we get D equal to S1 minus S2. Then the next step, we find the test statistic, which is the mean D or the D mean of the difference. So remember, for example, if we have 10 values in two different, the two samples must have the same size. So if the size of the sample 1 is 10, the size of sample 2 must be 10 also. Now we find the difference of pair of each of these values from each data. So we're going to get D1 up to D10. Then the next step, we find the D average. So the D average will be the sum of all the Ds divided by the sample size. So again, what this means, D here means the difference of each pair values in the two samples. So again, if the sample size is 10, which means we are going to find D1 up to D10. Then after that, we find the D mean, or here we say the test statistics is the D mean or the mean D of these differences. So we had all the differences of the values, then we divide by the sample size. So in order to do a t-testing for the difference of two sample mean, there are three conditions that are required to conduct the test. One is the samples must be randomly selected. So the samples must be randomly selected. Then second, the sample must be dependent. So they must be paired dependent. Then the last, both population must be normally distributed. So these are the three conditions we have to meet again. The samples must be randomly selected. Also the samples must be dependent. And then both populations must be again normally distributed. So if these conditions are met, then the sample distribution for D mean is approximated by a T distribution with n minus 1 degree of freedom, where again the n is the number of data pairs, which will be the sample size. So we know we are doing T distribution, so we still need our degree of freedom, which normally the T table, the row values are the degree of freedoms. So the symbols used for the t-test for the population D, N is the number of pairs of data. So lowercase n is the number of pairs of data, which sometimes we say the sample size, because again, the two samples must be the same size. So if I have 10 values, then I'm going to do 10 pairs. So n is the same as the sample size, which in this case will be the number of pairs of data, because we are taking one value from the two samples from each of the samples. Also, we have D. The lowercase d is the difference between the entries for the data pair. And we saw d equal to S1 minus S2 means the difference of the first value in the first sample minus the difference of the first value in the second sample. Then we also use the mu d. This will be the hypothesized mean of the difference of the paired data in the population. So again, hypothesized mean of the differences of the paired data in the population. Then we have a D bar, which will be the mean of the difference between the paired data entries in the dependent samples. So D bar is equal to the sum of all the Ds divided by the normal pairs or the sample size. Then we have S, uppercase S and lowercase d. This will be the standard deviation. So SD, the standard deviation of the differences between the paired data entries in the dependable samples. So the formula will be the sum of D minus, here we can see that we are, instead of using the sample values, let's say the X values in the first sample or the X values in the second sample, we are not using them. So that's why we find the difference of each value in the sample. Then we find the mean of the difference. Now, when we are going to find the standard deviation, remember standard deviation in descriptive statistics, the S value minus the S mean all squared plus the next S value minus the S mean all squared plus. We had all the values, different squares from the mean square and the value square. The same apply here. We can see the formula here. Now we take the first D minus the D bar all square plus the second D minus D bar all square plus the third D minus D bar all square. So it depends on the size of the sample. We're going to again subtract the mean D from each D value and square it and add all together. Since we are dealing with sample, we divide by n minus 1. Same concept as descriptive statistics. This is the same, again, if you evaluate this is the same as writing the sum of d squared minus the sum of d squared over n, all divided by n minus 1. Because you can say sum of d over n here is the same as the d bar, and it's squared because squared. Then we have the d squared by itself, all over n minus 1. So both again are the same. So the test statistics again is d bar, or the mean d, is equal to the sum d over n. Then the standardized test statistics, to find the t value now, it will be d bar, or the mean d minus the mu d divided by, this is standard error, but it will be the SD divided by square root of n. And we are very familiar with this formula, standard error, which is the standard deviation of the sample, SD divided by square root of n. Then we are doing t distribution. So in t table, we always need a degree of freedom. So here, degree of freedom will be n minus 1. So now let's state the steps step by step. Almost we went through it, but let's summarize everything here. So hypothesis testing for two dependent samples. First, we have to state the claim mathematically, which means we have to identify the null and also the alternative hypothesis. In symbol, we say state the null HO and HA. HO is our null hypothesis. HA is our alternative hypothesis. So first we state it there. Then second, we have to specify the level of significance. We should identify the alpha. So we can see that the steps are almost the same as we did a hypothesis testing for only one population or one sample. It's the same step. we are doing t-testing, so we need our degree of freedom. So identify degrees of freedom and sketch the sample distribution. Degree of freedom is always the sample size minus 1. In this case, will be the number of pair of the sample values minus 1. Then after that, we are going to sketch our distribution and the sketching for normal distribution for us to determine the critical values. So here, next we determine the critical value using table. Again, table 5 here means using the T table. We are going to use the T table. And if n is greater than 29, then we use the row infinity. What we mean, the degree of freedom. If it's 30 going up, then we have to use the row. In the table, we have infinity row. Other than that, we have row 1, 2, 3, all the way. Then next, we determine the rejection region. Again, from the distribution, our graph, we can see the critical. We also find the critical value. We can see if the critical value fall inside the rejection area or accepted area. Rejection or accepted means the HO. Whether we reject HO or we accept HO or fail to reject HO. So here we have to calculate the D bar and also the SD, which is the standard deviation. Then we use the table. So we know the D bar will be the sum of all the D divided by N. Then to find the SD, we say D minus D bar all square plus D minus another D bar all square. Depends on the size of the sample. But we find the difference of each value minus each value of the D minus the D mean all square, we sum all. Then we divide by N minus 1. Then we find the square root. So as we said earlier, this formula looks exactly like descriptive statistics when we are looking for our standard deviation. So after we know the standard deviation, first of all, in order to find the standard deviation, we find the D bar or the D mean, because we need a D mean in our standard deviation. After that, if we know the standard deviation, we can find the standard error now. So now we can find the T. And the T will be the standardized test statistic. So it will be the D bar minus mu D over the standard deviation SD divided by square root of N. Again, this is more or less like the standard error or the standard deviation for the sample. So it will be D bar again minus mu D. Then we know the T value. We went to the table, everything. So we make a decision to reject or fail to reject the null hypothesis. So we said that if the T value we get is in the rejection region, then we reject HO. Otherwise, we will fail to reject HO. Then we need to interpret the decision in the context of the original claim. So let's see an example, and this example will go through the step as we went through step 1 to 9. Mostly step 1 to 8 is the most important. So let's see the example here. Here we say that a golf club manufacturer claims that golfers can lower their scores by using a manufacturer's newly designed golf clubs. So 8 golfers are randomly selected. So that can be our sample, randomly selected, and then each is asked to give his or her most recent score. After using the new clubs for 1 month, the golfers are again asked to give their most recent score. The scores for each golfer are shown in the table, assuming the golf scores are normally distributed. And is there enough evidence to support the manufacturer claim at alpha equal to 0.10? So here the manufacturer claim here is that, let's go through a golf club manufacturer claims that golfers can lower their scores by using the manufacturer's newly designed golf clubs. So because of that, again, 8 golfers are selected. They give them the new golf club. They use it, they record their score, and later they give them the old one when it's a little bit older, and they record that score again. So our goal here now, we are going to do hypothesis testing and see that the claim that the golf club manufacturers claim that the new golf clubs can give higher score than the old golf club. Or we say that the golfers claim, manufacturer claim that the golfers can lower their scores by using a manufacturer new one. They can lower their score. I think in a golf game, I don't know much about golf game, but in golf game, when your score is lower, that means you are winning. If you score high, you are doing bad. So this is the data. So this is the data we're going to follow. You can see that, as we said, this is dependent because we use the same golf club. So yeah, after using the new club for 1 month, the golfers again has to give their most recent score. So the same golf club we use twice after 1 month, second score. So let's do this hypothesis testing and see if the claim made by the golf club manufacturer can be true or false, or we should reject it or accept it. The claim is that if you use the new golf club, your score will be lower. When the golf club become older, the scores get higher. So let's start. So the first thing we need to do, of course, is to find the D. The D again will be the pair here. We see the difference of the two scores, old and new, old and new, old and new. So we're going to have D8, D1 to D8. So we say the old score minus the new score for the D. So here we state our HO. Remember the claim. So MD should be less than or equal to 0. MD should be higher because here we say that MD will be lower score. So now we have the alpha is given already. Degree of freedom we know is 8. 8 minus 1 is 7. So when we get our rejection region, based on the alpha value here and the degree of freedom, we get 1.415. The alpha value is 0.10. And this is not a two-way because the claim was that the new golf club score is what? Lower. We reduce the score. So the MD will reduce. So we say it's less than or equal to 0. Then we go against it, say no, it's greater than 0. So we find our T value based on the degree of freedom and the alpha given to us. Again, in the T table, we go to the row 7 and we go up. Since we are doing only, we are not doing two pair, we're doing only right. So we go to the top, then we look at 0.10, the column of 0.10. So intersection of the column of 0.10 and the row of 7, we get 1.415. So now we know our rejection area and accepted area. So now we need to do our test statistics, see if the value will fall either in the rejection or accepted area, the brown area or the blue area. So the first thing is a long process. Remember, we need to find the D. So we find the D, we have 8 values, so we find the difference, 8. Then we square it also. So 89 minus 83, 84 minus 83, 96 minus 92, all the way down. Because we have 8 values, so we have to find the D for each value, as we said in the theorem. We need this square in our formula, so that's why we square it. So we know the D's now. To find the D bar or the D main, we had all the D, it was 13. Then 13 divided by 8, the size is 8. So that gave me 1.625. Now we need a standard deviation. We need a standard deviation. So the standard deviation is the sum of this square minus the sum of d square over n. The sum of d square the sum. This means we square all the d, then we sum it. That's what we did. D square with d square, or we sum it. But here means we sum everything, then we square it. So the first one here, d square sum will be 87. Then sum d all square will be 13 square over the size 8 minus 1. Again, if you do your arithmetic operation, we get 3.0677. So the next step now, we move to our test test statistics. We know that the reason why we look for D and the reason why we look for SD, we need a D and a D mean in order to find the SD. So now we know the D mean is 1.6225, and we know the SD is 3.0677. The size is 8 again, so square root divided by square root of 8. Our MD will be 0. That's what we have here. So we get 1.498. 1.498 fell under the blue area. So this means we are going to reject HO. As we said, the brown area is to accept. The blue, after the 10%, or alpha is 0.10, and the degree of freedom of 7 gives us 1.415 T. So our decision here is that we, at 10% level of significance, because they gave us 0.10, the result of this test indicate that after the governors used a new crop, their scores were significantly low. So we reject the HO. So that would be the conclusion on this topic. Again, here we study about how we can do hypothesis testing using two samples. The samples are dependent samples. So we see that the first step again is to state our HOHA. Then the second step, we should know our D. Then we should know the D mean. Then we can find the SD. When we find the SD, we can be able again to find our T stat. When we get our T stat, we have to construct our rejection and accepted region by using the alpha that was given to us. So the alpha value that is given to us with the degree of freedom based on the number of samples, we can be able to find our critical value where we're going to get a barrier for rejection and so also accepted HO. So when we get that, now the value we get for the T-stat, we can know whether it falls in the rejection area or it falls in the accepted area. In our question here, our rejection area is the blue because alpha 0.10 and degree of freedom 7. If you go to the 7th row in the T table and you go up and look at column for 0.10, you will get 1.415, the intersection. So when we get our D value to be 1.498, then it goes to the blue area, so it's reject. Always from left to the value will be our accepted HO. So we rejected the HO. So again, wish everybody the best and thank you for your time and watching this video.